two, three things that we need to see. First, starting with, we have, let's say, a number line. Okay. So 0, 1, 2, 3, 4, -1, -2, -3. All these numbers are called integers. Okay. Integers means no decimals, nothing. Okay. No fractions, no decimals, just the complete number. That's what we call as integers. So if a question mentions integers, that means it could be all the positive integers, it could be 0, it could be the negative ones as well. Okay. Unless the question specify positive or negative, we'll consider all. Okay. That's one thing. A lot of people make mistakes just because they've, forget to consider 0 and negatives. They consider only the positive integers. So this is one mistake we need to avoid at all costs. Okay. Second, if 0 is neither positive nor negative. Right? So it's not positive, it's not negative. It's kind of neutral. If we say numbers, if the word is numbers, numbers means it could be integers or it could be non-integers as well. Okay, it could be both. So we can, number could be 2, number could be 2.5, it could be integer, non-integer. Again, it could be positive, negative, 0, anything is possible. Okay, again, unless mentioned otherwise, we'll take all, we'll consider all. Okay. Then odd versus even. What's an even number? Even number is something that is divisible by 2. Simple. Okay, something which is divisible by 2, it's even. Anything ending with 0, 2, 4, 6, 8. Okay, anything ending with any of these digits is even. Simple. Okay, 0 is also even. And in case you're confused, 0 is even. Any number ending with 0, 2, 4, 6, 8 is an even number. And odd, definitely anything not divisible by 2 is odd. Okay. Any number ending with 1, 3, 5, 7, 9. Okay, any number ending with one of these digits would be definitely odd. If we add two numbers, odd plus odd, the sum would be even. Okay, 3 plus 5, sum would be even. Okay, in case, and again, you're not able to remember something, take some example, you'll be able to figure it out easily. Okay, or whether it is addition, whether it is subtraction, the result would be same. Okay, whether you add two odd numbers, whether you subtract one odd from another, the sum would be even. Sum or difference would be even. Again, whether it is addition or subtraction doesn't really matter. So whatever is the outcome in case of addition, same outcome will be there in case of subtraction. Two even numbers are getting added, obviously the sum would be even. Okay, again, it could be positive, it could be addition, it could be subtraction. If it is one even and one odd, then the sum would be odd. Sum or difference would be odd. Okay. So for sum or difference to be odd, one number has to be even, another number has to be odd. Okay. And if there are more than two numbers, okay, let's say there are some even numbers, some odd numbers, they're getting added or subtracted, what will be the final result? Final result in terms of being odd or even. That's what we're talking about again. So the even numbers, you can simply ignore them. Okay. Ignore as in they will have no impact on the outcome. What we need to see is how many odd numbers are there. That's it.
So can you repeat this part again?
So if we have more than two numbers getting added or subtracted, what would be the final outcome? That's what we are trying to see. Okay.
Mm-hmm.
So in that list of numbers, okay, 4, 5, 6, doesn't matter how many numbers are there. Whichever numbers are even, you can simply ignore them. They'll have no impact on the outcome. Okay. The outcome will be decided by how many odd numbers are there. That's it. For example, you add 3 plus 3 plus 6. Okay. What is this answer? Even, right? I mean, even if you ignore this one even number, the final outcome still would be decided by these two odd numbers, right? Or let's say if we have 3 plus 5 plus 7 plus 2, whether you count this 2 or not, it doesn't matter. Only this sum will decide whether the number is, I mean, the final sum is odd or even. Right, Abhilasha? This is the point I'm trying to make.
All right, sir.
Okay. The even number doesn't matter. I mean, we can choose to ignore it. Simple. So how many odd are there? That will decide, for example, if we have two odd numbers. So if number of odd items is even, let's say we have two odd numbers, four odd numbers, six odd numbers, the sum would be even. Okay. For example, two odd numbers, the sum would be even. And if we have like 3, 5, 7, 9, these odd, I mean, number of terms, number of even, number of odd terms is this, the product would be, or the sum would be even, odd. Okay, so we added three numbers, the sum would be odd. Okay, it all depends on how many odd digits are there, how many odd numbers are there, that's all, nothing else. Okay, so that's one thing. Second, product. Okay, if we add, subtract, sorry, if we multiply two numbers or more than two numbers, even integer multiplied with any integer, the final outcome would be even. Simple. Okay. If there are 10 numbers that are getting multiplied, just one number is even, the entire product would be even. For the product to be odd, all the numbers must be odd. Okay. For a product to be odd, all the numbers must be odd. Simple. Even if one number is even, the entire product would be even. Okay. With division, there is nothing fixed with division. For example, one even number upon another even number, we can have very different results. For example, 4 by 2 is 2, which is the result is even. 6 by 2 result is 3, odd. Okay. Again, one even number upon another even number. 8 by 6 is not even an integer. So with division, we cannot have any fixed thing. We cannot have any fixed rule. The only fixed rule we can have is odd number upon even will be a non-integer always. No even number will divide odd number ever. Okay. So that's the only fixed thing. Nothing else is fixed. Okay. So with division, nothing is fixed. That's what we are looking at. So that was odd and even. Another point that we want to see is LCM and HCF. Okay. And after that, we'll move to questions. Let's start with LCM. LCM is least common multiple. And before that, there is something called prime number. Again, we need to tackle that as well. Prime numbers. Prime number, as we know, is something that is divisible. And first of all, prime numbers are only positive integers by definition. And positive integers which have only one and the number itself as its divisors. Okay, that's the definition of a prime number. Okay, I mean, this is not a technical definition, this is more of a practical definition. Okay, technical definition is a number which has a positive integer which has exactly two positive divisors. This is what a prime number actually is. Okay, so 2 The only divisors are 1 and 2. 3 only divisors are 1 and 3. 5 only divisors are 1 and 5. So that's about it. Okay. 1 is not a prime number. Why? Because it doesn't satisfy this definition. It has only one positive divisor, which is 1. It doesn't have two positive divisors. A prime number must have exactly two positive divisors. Okay. Understood, guys? Let's take one or two questions. Just open the sheet. Let's try 1 second.
You were saying something about LCM and HCF.
We'll come to that. We'll come to that. Let's tackle odd, even, and prime number question first. Okay. We'll discuss all those things. Let's do 1, 2, and 3. First, second, third. Let's give them a try. Okay. Okay, let's see the questions. No answers for the third? Jay, Lakshay?
Didn't understand how to
We
do
don't
it.
understand what to do. Okay. Okay, let's see. P and K are even. P and K are even. Okay. And Q is odd. Which of the following cannot be even? Okay. Let's see. Cannot be means other four. I mean, the other four options can be even. I mean, maybe for just one case, but the other four can be even. That's what we're looking at. Okay. Let's see. P into K definitely would be even because both of them are even. P into Q would also be even because one of them is even. K upon P. K upon P might be even, right? One even upon another even can be even, right? 8 by 4, 8 by 2 can be even. So C is also out. QP upon K. QP upon K. It can still be even, because P upon K, both are even, P and K. So if P is 8, K is 4. So this definitely would be even, the entire thing. Q upon P, odd upon even, definitely. It's even I mean, it's actually a non-integer. This is something that cannot be even for sure. Okay. So the question can be which of the following cannot be even. The question can also be which of the following cannot be an integer also. I mean, that question would also do. Right? So E is your answer. Clear, Abhilasha? All good with this?
Yes, sir. I got the first two answers, but not the third one.
Acha, you got the first two, not the third one. Okay.
Yeah.
Okay. I mean, we'll get to know a lot from the third one, but let's see his second one first. ABC are integers. Okay, it's given to me. And AB square upon C is positive even integer. Positive even integer. Okay, it's given to me. Which of the following must be true? Okay. So if you see AB square is equal to some even integer. Sorry, AB square upon C is an even integer. Multiply both sides by C, what do you get? AB square is equal to C into some even integer. Okay. C into some even integer would also be an even number for sure, even integer. So AB square is also even. We know that. Which of the following must be true? Must be true means must always be true. Okay, so we need to take care of that thing. Must be means must always be true. Okay. First, A into B is even. If AB square is even, A into B, I mean, A into B is even means out of A and B, one of them is even. Definitely that is the case here. Okay. I mean, see, if any number X is even, let's say, then X square would also be even. If some number X is odd, X square would also be odd. So whether it is AB square, whether it is AB, whether it is A square, B square, whether it is A square, B, all of them would be same in terms of being odd and even. Okay, they won't be different. Right? So if AB square is even, definitely AB is even. So first one is true for sure. Okay. Second, A into B is positive. Now, A into B, see, product of two numbers. When is product of two numbers positive? When both have same signs. Either both are even, both are odd. Okay. Now, from
Sir,
this,
sorry, sir, can you repeat this once again?
yeah, so product of two numbers, let's say product of two numbers A into B is positive. When will it happen? When is the product of two numbers positive? When they have same sign, either both of them are positive or both of them are negative, right?
Yes, sir.
Right. So saying that they are positive, we are talking about the signs, whether
Hmm.
both of them are positive or not. Do we
Yeah.
know whether both of them will have same sign?
No.
See, what it says is A into B square is some positive even integer upon C is some positive even integer.
Hmm.
The only problem here is that we have a b square. For example, if a is positive and b is negative, let's say b, ab square will still be positive, but a and b can be negative. Okay, so second is not always true. Second might be true, but the question is must be true, must always be true. Okay, got this point? Jay, how do you get second b?
No, I actually didn't consider negative. So I just thought
Okay,
about this.
but how about the first one? You didn't get it? Kind of. I mean, a into b has to be even.
Yeah, I understood it
Understood
now.
now? Huh. Okay.
So, like, can we say that if we that is A upon B is even, so A will be even,
Just
like,
think of it this way, na? X upon y is some even number.
so X
X
will
is
always
equal to
be.
even into y.
Uh,
Then only it can be even. And you divide something and you get even result. Can odd upon something be even? No, it can't be. The numerator has to be even because it's y into some even integer, so got to be even.
okay.
Okay. Hmm. So first is true, second is not always true, third c is even. Again, a b square upon c is even. Simply saying x upon y is even. We can be sure about the numerator that x is even, but what about the denominator? It doesn't need to be. 12 upon 3 is even. Denominator doesn't need to be even. Okay, it might be, it might not be. We don't know. So only first is true. Okay. So uh, A, only the one out of three options, one is true. Let's see third. Third is a good question, which is the following is a prime number. What is the definition of prime number? A number which is divisible only by one and itself. That's what we call as a prime number. For all practical purposes, this definition is fine. No problem about that. Okay. I mean, we just need to remember that one is not prime. All other numbers will have to fall into this definition. Okay. Which of the following is prime number? Okay. Now tell me one thing. Let's say if I say let's say 5x. Okay. X is some integer. So 5x will be what? A multiple of 5. Yes. 5x, if x is an integer, 5x will be a multiple of 5. Some number in the table of 5. So 5x is a multiple of 5. What will be the next multiple of 5? Next number in that table? Hmm? 5x is some number in the table. What would be the next number in the table of 5? 5x plus 5? Yes. That's how the table of 5 works. We keep adding 5, we'll get the next number in the table. Okay. So 5x plus 5 will be what? Another multiple of 5? Next multiple of 5? Next multiple of 5 means it's divisible by 5. Yes or no? Right? So will 5x plus 5 be a prime number? I'm asking this question. 5x plus 5. Will it be prime or not? Is it divisible by any number other than 1 and itself?
It won't be prime.
It won't be prime because it's divisible by 1 by itself and by 5 as well. Okay, clearly this number is bigger than 5. So it has a 1 as a divisor, the number itself as a divisor, and 5 also definitely as a divisor. So it's a non-prime number. Okay, is that clear, Jay, Lakshay? Is this point clear? Because that's all we need to do in this question. We'll see with every option, right?
Yeah.
Yeah. So first of all, I think all the options are wrong here. It got to be 13 factorial plus some other number. I mean, it's actually none of these, but let's see. That's besides the point. Uh, 13 factorial is what? 1 into 2 into 3 into 4 till 13. Okay. So 13 factorial is a multiple of 2, it's a multiple of 3 as well, it's a multiple of 4 as well, it's a multiple of all the numbers till 13, first of all. So 13 factorial plus 2 would be a multiple of 2, definitely, because 13 factorial itself is a multiple of 2. It'll be some number in the table of 2, a very large number, but still a number in table of 2. 13 factorial plus 2 will be a multiple of 2, non-prime for sure. Same way, can we say the same thing about every number? 13 factorial will be a multiple of 3 as well. So plus 3 means next multiple of 3, non-prime. Plus 4, next multiple of 4, non-prime. None of these, I mean, there should be one option also, which is none of them. So none of these numbers is prime. Right? Can we say that?
Yep.
Yep. So, but again, more than the answer, it's the logic that we are checking here.
But then, sir, what would be an example of something that could be a right answer? Can you give me can you give
So
an
it
example?
could be definitely, for example, let's say if you talk about 5 factorial. Okay. 5 factorial is 1 into 2 into 3 into 4 into 5. Okay. So 5 factorial plus, let's say 7 could be a prime number. Maybe. We'll have to check. Okay. Because, I mean, I'm not sure, but it could be. I'm not sure. So the answer in such case definitely would be none of them. Because it's very difficult to check what would be the next prime number. Right. So definitely one option should be none of them. And that's all we are checking here.
Okay.
Right, Lakshay? I mean,
Yeah.
it's the task is not whether you can find what is the next prime number or not. No. The task is to figure out that none of them would be prime. That is the task.
Okay.
Okay. Yeah. Okay. Is that clear? Yeah.
Like 13 factorial plus 15.
No,
Or
that
like
won't be because 13 factorial itself has 3 into 5. That means it itself will be a multiple of 15.
like 13 factorial plus 17, let's suppose.
Could be. We'll have to check actually.
So like there's no way we can figure out whether
There's
it
no
is.
way. That's what I'm saying. The task is not to figure out what will be the next prime number. It is to figure out that none of them would be non prime.
So we won't get questions like that.
No. It'll be. I mean, there's no question which asks you what would be the next prime number after 1,050,000. No. Okay. So that's beyond our scope, right? I mean, this 5 factorial plus 7 would be what? 5 factorial is 120 plus 7, 127. Is it a multiple of some number? We'll have to check. Okay. So, I mean, it's very difficult to figure out. There are ways to figure out, but it's beyond our scope of things. Okay.
Okay.
Clear? So, okay. Let's do one more question, which is question number. Let's do one thing. Let's see some other concepts, and then we'll go to questions. Before getting to LCM and HCF, let's see one more thing, which is factors or divisors. Okay. For example, 10 has how many? I mean, mostly the questions will talk about positive divisors. So we'll have to consider only the positives, not the negatives. So 10 has 1, 2, 5, 10. These 4 positive divisors. Divisors of factors, it's one and the same thing. Okay. If we talk about, let's say 20, best way to get all the factors is write them in pairs. Pairs as in 1 into 20 is 20, 2 into 10, 4 into 5 is 20. Okay. That way you won't miss any number. Okay. Let's say if we talk about 36, 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. Okay. That's how we can write all uh, the factors. Now, this way, I mean, it's if there is a big number, it's very difficult to write all the factors. So sometimes the questions simply ask, what is the number of positive factors? Okay. What is the number of positive factors? So if we have to see only the number of factors and not the values of factors, we don't have to do this exercise. There's another way to calculate that. What is that? Break any number 10, let's say 10, 20, whatever it is, into prime factors. Okay. For example, 10 is 2 raised to power 1 into 5 raised to power 1. 20 is what? 4 into 5. But 4 is not prime. So we'll write it as 2 raised to power 2 into 5 raised to power 1. I mean, these numbers must be prime, 2 and 5. Okay. For example, 36. 36 is 4 into 9. 4 is not prime, 9 is not prime. So we break them further, 2 square into 3 square. Okay. These two base numbers must be prime. That's the whole idea. Okay. So break any number n as a square, let's say a raised to power x into b raised to power y, where a and b are prime numbers. Break them into prime numbers. So the number of positive factors will be given by x plus 1 into y plus 1. Okay. The powers x and y, x plus 1 into y plus 1. That will give me number of factors, number of positive factors. Okay. For example, x and y are 1 each here. So 1 plus 1 into 1 plus 1. 4 positive factors. We know 10 has 4 positive factors. 20. X is 2, y is 1. So x plus 1 into y plus 1. 6 positive factors. We have already seen it will have 6 positive factors. 36. X and y is 2 and 3. Sorry, 2 each. So x plus 1 into y plus 1, 9. We have seen that there'll be 9 factors. Okay. So if the question is about only the factors, okay, number of factors, we don't have to write all the factors. We just, do this exercise, break it into prime factors, and get to the number of factors straight away. Clear? Okay. So if the question again, if it is about number of factors, we don't have to write all the factors. But if we talk about what numbers might divide it or what might not divide it, we better break it into prime factors, a number, and then see what could be the divisors. Okay. Understood, everyone? Any doubts till this point? Okay. Now let's see LCM and HCF. Okay. LCM by definition means, what is the literal meaning? Least common multiple. Okay. So we're talking about, so let's take 2, 3 numbers randomly. Let's say 24, 36, and let's say 80. Okay. Any numbers randomly. We need their LCM. First step, break them into prime factors. Okay. 24 is 3 into 8. 8 is not prime, so 3 into 2 cube. 36 is 4 into 9, 2 square into 3 square. 80 is what? 5 into 16. So 16 is 2 raised to power 4. Okay. So break them into prime factors first of all. Second step, take all the prime factors. Take means write them at one place, 2, 3, and 5. These are the only prime factors that we have in these numbers. And third factor, take their highest power. Okay. So highest for 2 is 4 for the power. Highest for 3 is 2. Highest for power 5 is 1. So this is what we're talking about. This is your LCM. Okay. Got it, everyone? So this is least
Can you
common
repeat the last part?
So, okay, I'll repeat the all 3 parts. Break every number into prime factors, first of all. Second, take all the prime factors. 2, 3, and 5 are the only ones there. And then take their highest power of each factor. Highest power for 2 is what? It's 2 here, 3 here, but the highest is 4. Okay. So we take 2 raised to power 4. Highest for 3 is square. t square. Highest of 5 is 1. This is your LCM. Okay. 2 raised to power 4 into 3 square into 5 raised to power 1.
Got it.
Okay. And I mean, logically, if we see, why do we have to take all prime numbers in their highest powers? I mean, we should understand it logically as well. Okay. I mean, one is memorizing it, another is understanding it logically. What is it? It's a multiple. That means it's a multiple of 24. It should be a multiple of 36. It should be a multiple of 80. Okay. 24 should divide LCM. 36 should also divide LCM. 80 should also divide LCM. Now, if, for example, we don't take 5 as part of LCM, okay, would 80 divide that number? No, it will not be a multiple of 80. So we have to take all the prime factors and their highest power. For example, if we take only 2 cube in LCM, would 80 divide it? No, because it has 2 raised to power 4. It won't divide it. Got it, everyone? The logic behind taking all the prime numbers and their highest power. So that every number will be able to divide that LCM. That's a purpose. Okay. Now, same way, let's see HCF. HCF, highest common factor. Okay, I mean, we also call it GCD, greatest common divisor. Okay, it's one and the same thing, obviously. Highest, greatest factor divisor. Exactly same thing. Okay, so they can be used interchangeably. Let's take the same set of numbers 24, 36, 80, and again, first step is break them into prime factors. So 3 into 2 cube, 36 is 2 square into 3 square, 80 is 5 into 2 raised to power 4. Okay. Second, take only the common prime factors. For example, 2 is the only one which is common. Okay. Had it been like this number being 240, let's say. Okay. So we would be having this. And 2 and 3 both would be common. 2 and 3 is here, 2 and 3 is here, 2 and 3 is here. Okay. So let's say the numbers are 24, 36, and 240. Common prime numbers are 2 and 3 only. Third, take their lowest power. Okay, take lowest powers of each prime factor. Lowest for 2 in all these 3 numbers is what? 2 square. Lowest for 3 is 3 raised to power 1. This is your HCF. Okay, got it, everyone? So in LCM, we take all primes and their highest power. In HCF, we take only the common ones and their lowest powers. That's what we do. Okay, and again, it's a factor, it's a divisor, it's a common divisor. It must divide, HCF must divide every number. That's why we take only the common ones and their lowest power. Okay. For example, if we take 3 square in HCF, would it divide 240? No. Would it divide 24? No. That's why we take the lowest powers. Okay, got it, everyone? Any doubts, any questions with this? Let's take up some questions. So a lot of questions in numbers would be based on factors and LCM, HCF, those kind of things. Okay, let's see. Try question number 5. And 7. $14 and just one more, 16. Try these questions. Okay. 5, 7, 14, 16. Yeah, give them a try. Okay, let's see the questions. Starting with fifth. K is a multiple of 24. So K is equal to 24 into something. No, it could be 24 into 1, it could be 24 into something more. That 24 means we are talking about 3 into 2 raised to power 3. Okay. 3 into 8, 3 into 2 cube, and it could be something else also. But what it means is K is a multiple of 24 means that means it has at least 3 raised to power 1. It has at least 2 raised to power 3. This is the least it has. K. Okay, it can have more, but this is the least it will have. But it's not a multiple of 16. That means it doesn't have 2 raised to power 4. So minimum power of 2 that it has is 2 raised to power 3, but it doesn't have 2 raised to power 4. That means K has only 2 raised to power 3. Getting my point, everyone? K doesn't have 2 raised to power 4. If K had 2 raised to power 4, it would be a multiple of 16 as well. 16 is 2 raised to power 4. That means for 2 only, the power is fixed. Okay, only for one prime number, 2, the power is fixed, which is 3, 2 raised to power 3. It doesn't have any more 2. But it can have other stuff, it can have 3, it can have more number of 3s, it can have 5s and everything. Getting my point? Now the question is,
So
which are the, yeah,
can you explain it again? Like this 2 raised to power 4 and
K
only
is
2
not a
raised to...
multiple of 16, right?
Okay,
That means multiple of 16 means 16 is 2 raised to power 4.
right.
That means K doesn't get divided by 16, right? So that means,
Okay,
16 means 2 raised to power 4. That means if K had 2 raised to power 4 in it, it would have been divisible by 2 raised to power 4,
right.
right? So
Oh,
it
okay, so
does,
that...
the power of 2 is not 4. It's less than 4.
Oh,
It's maximum 3 in K.
okay, oh, got
But
it.
for other numbers, it could be anything because it's a multiple of those things. Getting my point?
Yes.
All right. So which of the following cannot be an integer? Okay. K by 8, 8 is 2 raised to power 3, definitely would be an integer, out. K by 9, there is no limitation on how many 3s it can have. There's no limitation. It doesn't say it is not divisible by 3 raised to power something. No. That means any number can be there. K by 32. 32 is what? 16, 2 raised to power 5. So if it is not divisible by 2 raised to power 4, how can it be divisible by 2 raised to power 5? That's your answer. K by 32. Okay. If we see other numbers, 36 has 2 square and 3 square. It can have 3 square. It definitely has 2 square. So can be a multiple. K by 81. 81 is 3 cube. 3 raised to power 4 can be. There's no restriction as to how many 3s it can have. Okay. But K by 32 definitely will not have. Okay.
Sir, I didn't understand.
The entirety of it or some part of it. See, if I say K is not a multiple of 16, K is a multiple of 24, that means K by 24, 24 will get cancelled with K, right? Abhilasha?
Yes, sir.
Yep.
Yeah.
24 is what? 3 into 2 cube. That means
Yeah.
in the numerator, we must have 3, we must have 2 cube at least. Okay. Now
Yeah.
it says K is not divisible by 16. K is not a multiple of 16. That means 2 raised to power 4 will not get cancelled with K in the numerator, right? That means K doesn't have
2 raised to power
2 raised
4
to
as
power
a
4. It
yeah.
doesn't have. Okay.
Yeah.
It has 2 raised to power 3, but not 2 raised to power 4. Okay. But it can have 3, it can have other numbers as well. Okay. Because it says it's a multiple of 24. It means 24 into something can be K. Getting my point, Abhilasha?
Yeah.
The only
Yeah. I
restriction it
got
has
it in
is,
this part. After that, I didn't understand.
okay. So K by 8. Does K have 8? Does it have 2 cube?
Yes.
It has. So it's an integer, out.
Yeah.
K by 9. Can it have 3 square? Is there any restriction on
No.
3? No, it can have.
But isn't it like,
It's a multiple of 24.
yeah, but see what I understood was it has to be 2 raised to power 3 into
Ah.
3 and into some number.
Into some number. It could be that some number could be 3 also, no?
Okay, okay,
That some number can be anything actually.
okay.
Okay. See, there is no restriction on other numbers. The only restriction is with 2 raised to power 4. I mean, it cannot have more than 2 raised to power 3. The only restriction is for prime number 2 for no other number. Okay.
Okay.
K by 36, if you see, 36 is what? 3 square into 2 square. Can it have? Yes, it can have.
Yeah.
No problem. 81. 81 is 3 raised to power 4. Can it have 3 raised to power 4? It might have. Right? K by 32. 32 is 2 raised to power 5. If it doesn't have 2 raised to power 4, how can it have 2 raised to power 5? Okay. So K by 32. Right, Abhilasha? All good?
Yeah, yeah.
Hmm. All right. Lakshay? Is that clear? I think you didn't answer for 5th. So
Yeah, I got it now.
yeah. Yep. So that's a good question. It doesn't need a lot of calculation. It's a purely conceptual question. Okay. All right. 7th is also similar. What is the greatest integer m for which 30 factorial upon 3 raised to power m is an integer? Now 30 factorial is what? 1 into 2 into 3 into 4 into 5 till 30. It's 30 factorial. Now, if we have 1 3 in the denominator, will it divide 30 factorial? Yes, it'll get cancelled. If we have one more 3 in the denominator, will it get divide? Will it divide? Yes, it'll get cancelled with 6. Cancelled as in a 3 raised to power 2 is 6. If we have 2 more 3s in the denominator, will all those 3s divide the numerator? Yes, because it'll have 9 somewhere and it'll get cancelled. So how many 3s we can have in the denominator? It's simply decided by how many 3s we'll have in the numerator. That's all. Okay. So just write table of 3 till 30. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So we'll have 3 only in these numbers in the numerator, right? So 1, 3 here, 1, 3 here. 9 has got 2 3s. Okay, 9 is 3 into 3. 12, 1, 15, 1. 18 also has 2 3s. It's 9 into 2. So 2 3s here, 1 here, 1 here. 27 has 3 3s, 3 cube. Okay. And 30 is, again, it has 1. 1, 2, 4, 5, 6, 9, 10, 11. 1 second. 1, 2, 4, 5, 6, 8, 9, 10, 13, 14. So we can have up to 14 3s, 3 raised to power 14. And all those will get cancelled with the numerator, which is 30 factorial. Okay. How did you get 10, Jay and Lakshay? Did you use some other thing, actually? I mean, you just did, there would be 3, I mean, 3 raised to power 10 is equal to 30. Sorry,
Yes, I
3 into
did
10,
factor
the multiple of 3.
9 and
So you
27.
didn't do the, I mean, these numbers
I
will
just
have more
did
than
that.
1 3.
Yeah.
Yep. Yep. Same problem for both. Yep. I mean, those numbers will have multiple 3s, 3 raised to power, more than 1. So definitely, we'll have to count more than 1. Okay. All good now? Jaya, Lakshay, Abhilasha. Any doubts here?
Yes, sure.
Okay.
Sir, why did you multiply on top? Why did you do 4 times? So like 3 times 3 times 3 times 3? Like
Here?
just yeah.
So see, what I'm saying is, dividing by 3 simply means how many 3s we can get cancelled with the numerator. That's all what dividing means.
Okay.
Okay. When we say, 3 raised to power m will divide 30 factorial, the first thing that comes to my mind is dividing simply means getting getting the denominator thing cancelled with the numerator thing.
Okay.
Just jump to that point and you'll get all the answers.
Okay. Got it.
I mean, that's what dividing means. No? 2 divides 6 because, 6 is 3 into 2. 2
Yes.
gets cancelled. That's what dividing means. Okay. So just think of it that way and it'll be easy.
Okay.
All right, then we are doing 14th. What answers we have? 14th? B. Let's see. X and Y positive integers, which of the following cannot be the greatest common divisor of 35x and 20y? So 35x is 7 into 5 into x, and 20y is 5 into 4 into y. Which of the following cannot be? That's the question. Okay. So, uh, 2 square into 5 is into y. That's what we have. 7 into 5 into x. That's what we have. Okay. So, how do we calculate LCM? Sorry, we are talking about greatest common divisor. Sorry. How do we get GCD? Take only the common primes. Okay. So 5 is the prime here, which is common. And do we have anything else as prime that will depend on x and y? Okay. Question is, which of the following cannot be? Okay. 5 definitely is out. Okay. 5 definitely would be GCD. 5 into x minus y. Question is, which of the following cannot be? I mean, if some number can be a GCD in some case, we'll remove it. But if x minus y is equal to 1, let's say, it can be out, right? It can be a multiple of, sorry, it can be a GCD, it can be a divisor of 35x and 5y, right? Jay, Lakshya, how did you get B?
So like I actually like eliminated the first A5,
First
then
5, I mean 5 definitely would be
like
GCD.
CDE. I thought like 35x, so we have that number, so that can be a
That can be a
greatest.
divisor. Yep.
20y can also be there,
Okay.
and 35 20x. I also
Let's
thought
see.
it.
Let's see. So, but 5 into x minus y, definitely. If x minus y is 1, definitely 5 would be a GCD, right?
But how do we know that like x minus y is 1?
See, question is which of the following cannot be? That means the other 4, if there is a possibility that a number can be a GCD, we'll remove it. Is there a possibility x minus y is 1? Yes. X is 3, let's say y is equal to 2. Where is the problem?
Okay, got it.
Okay.
But then 20x also cannot be, right? I mean,
We'll come to that. No, we'll see. So A and B are out for sure.
okay.
Okay. So now 20x, 35x, 35x is 7 into 5 into x, and 20y is 4 and 2 square into 5 into y. Can 20x divide both? That's what we're looking at. Divide by 20x. 2 square into 5 into x. 2 square into 5 into x. 5 get cancelled, x gets cancelled. Will it divide? Will 20x divide 35x? Never. This cannot be the common divisor. Okay, common divisor simply means it'll divide both. If it doesn't divide one number, I mean one part, definitely we don't have to check for the other part. Right? Jay, 20x will not divide 35x. Right?
Yes, yes. Okay.
But Lakshya, this is what you're talking about?
Yes, okay, got
So
it.
that
Yeah.
means this cannot be. That's your answer.
No,
I mean,
no.
that's your answer. Okay, that's what we're looking at. Which of the following cannot be
Okay.
a common divisor? So if it doesn't divide one number, that's not a common divisor. We don't have to check for the other one. Okay, let's see other numbers. 20y. 20y definitely divides one number. Okay, and can it divide 35x? 20y is 5 into 2 square into y. Okay, what if x is equal to 4 into y, some number? Let's say y is equal to 1 and x is equal to 4. It can divide both. No problem about that. Okay, so that's, I mean, 20y can be a possibility, 35x can be a possibility. 20x definitely is not a possibility. Okay, and can anybody tell me what would be the other number which cannot be a GCD? Like 20x, the other number would be 35y. Okay, because we have 20y. 20y means 5 into 4 into y upon 35y. This is another number that will not be an integer. Got it? Everyone? Okay. Jay, Lakshya, Abhilasha, all good?
Yes, got it.
Got it.
Yes, sir.
All right, let's see. 16th. 6 bells commence tolling together and toll at intervals of these many seconds respectively. In 30 minutes, how many times do they toll together? Okay. So first of all, let's say one bell tolls at every 2 seconds. So next time it'll toll will be at 4 seconds, then 6 seconds, then 8 seconds, and so forth. Okay. This other bell which tolls at after every 4 seconds, so it'll toll at 4 seconds, 8 seconds, 12 seconds, and so forth. Okay. 6 seconds, 12 seconds, 18 seconds, so forth. So what exactly we are looking at is we're looking at LCM of these numbers. Okay. When the next time they'll toll together, see, uh, one bell tolls at a multiple of 2. Okay, multiple of 2 seconds. One bell tolls at multiples of 4 seconds. One bell tolls at multiples of 6 seconds. Okay. So if we can find a common multiple, okay. So common multiple will be some time when all the bells will toll together. Okay. Is that point clear? We're looking at LCM, common multiple. Okay. Any doubts with that? We're looking at common multiple. So we have, what 2, 4, 6, 8, 10. We have, I mean, the prime factors 2, 2 square, 3 into 2, 2 cube, 5 into 2, 12 would be 3 into 2 square. So 2, 3, 5, that's what we have. Maximum power for 2 is 3, maximum for 3 is 1, maximum for 5 is 1. Okay, so they'll toll at 120 seconds. Okay, after every 120 seconds or after every 2 minutes, they'll toll together. Any doubts till this point, first of all? Okay. So after 2 minutes, after every 2 minutes, they'll toll together. Okay. I mean, after every 2 minutes, there'll be an instance where every bell is tolling. Okay. Now, in 30 minutes, how many times do they toll together? So 2 minutes, 30 minutes upon 2, 15 minutes. So should it be 15 or 16? Lakshya, you're getting 16. Jay, you're getting 15. So which one to go with? Lakshya, how did you get 16?
I um I took the LCM and then I did I think 2 times with
But LCM is 2 minutes, right?
yes,
120 seconds.
right.
So how did you get 16 in 30 minutes?
I think I did something wrong over here.
No,
Yeah.
actually 16 is correct. That's
Oh,
what I
really?
wanted to check. Why did you do 16?
I did.
See,
Let
they
me-
start together at 0 seconds, 0 seconds, let's say, I mean, at the beginning. And in
Okay.
next 30 minutes, they'll toll 15 more times. Right, Jay? Does that make sense?
Yeah, yeah. I just
Right?
did 30 by 2,
30
so
by 2, huh? So for example, in 4 minutes, so they start tolling right now. They'll toll again at after 2 minutes, they'll toll again at 4 minutes. So they'll toll 3 times because they one at the beginning and then 2 more times. Okay. So in 30 minutes, one at the beginning and 15 more times. So it'll be 16.
Okay. Oh, I
Okay.
know how I did. So I did LCM of everything and then took 2 as a common and then 4 as the highest multiple and then just I guess that's how I did it.
Okay, but
So
I don't think that was the right logic to do it. But anyway, so this is how we do it. LCM is 120 seconds, which is 2 minutes, and that's how we go about it. Okay.
Oh.
Right. Any doubts with this? All right. Okay. Now let's see one or two more things before we. Okay. Next thing is about remainders. Now let's say we divide 13 by 4. Okay. So obviously 13 is not a multiple of 4. There'll be some remainder. So how do we write 13 as? 13 is equal to 4 into 3 plus 1. Okay. So, 4 is the divisor and 1 is the remainder. Okay. So when we say x divided by y, remainder is r. We write it as x is equal to y into some integer plus the remainder. Okay. 13 divided by 4. 13 is equal to 4 into some integer plus the remainder. That's how we write it. Okay. The reason we write it this way is, there are many questions which can be solved easily by doing this. That's all. Okay, got it, everyone? And one more thing, remainder obviously has to be less than the divisor. By definition, remainder has to be less than the divisor. For example, if you're dividing by 4, okay, if divisor is 4, remainder can be 0, 1, 2, 3. Okay, it can't be anything more than 3. It has to be less than the divisor. Okay, got it, everyone? Then let's say if we have a plus b divided by x, and what would be the remainder? Okay, a plus b or a plus b plus c plus d divided by something, what will be the remainder? Okay, we can simply take a by x, the individual remainder when a is divided by x, individual remainder when b is divided by x, and add those two remainders. Let's say this is r1 remainder, this is r2 remainder. We add those two remainders. That's it. Okay. And if we have, let's say, a multiplied with b divided by x, so a by x remainder, let's say that is r1, b by x remainder, let's say that is r2. We simply multiply the two remainders, no problem. Okay, so if then in the numerator we have addition of few things, we can actually add the remainders as it is. If they are, if we have product of few numbers, we can actually multiply the two numbers, two remainders. Okay.
Again, some people don't will need to again divide R1 plus
Yeah,
R2 by
I was coming to that. So let's say it might happen that after multiplying or after adding the remainders, for example, we have 12 into 13 by 9, let's say. So 12 by 9 remainder would be 3. 13 by 9 remainder would be 4. The final remainder comes out to be 12, which is more than the divisor, which cannot happen. In that case, you divide it once more by the divisor and see what is the final remainder. That's it. Okay. So if the addition of remainders or product of remainders comes out to be bigger than divisor, it might happen. Then you divide it once more by the divisor, and that will give you the final remainder eventually.
Sir, can you repeat this part once again?
This part.
Yeah.
So see, we are multiplying the individual remainders, we are adding the individual remainders, right?
Yeah.
It might happen that the multiple, the product of the individual remainders is more than the divisor itself. It might happen, as is the case here. So, but remainder cannot be more than the divisor.
Yeah.
So in that case, you divide that product or sum again once more by the divisor.
Okay.
That's
Okay.
it. Okay, and then whatever remainder you get, that's your final remainder. Okay. So that's how it goes. So the point is, end of the day, you can add the remainders, you can multiply the remainders, no problem. Okay. And one more thing, which is divisibility rules. Which is, when is a number divisible by 2? When the number is even. Okay. Or the number ends with 0, 2, 4, 6, 8. Okay. Okay. Divisibility by 2, the number must end with 0, 2, 4, 6, 8. Any of these numbers. Divisibility by 3, sum of digits must be divisible by 3. Okay. For example, 42. 42 sum of digits is 6 divisible by 3. So it's multiple of 3. 4 last two digits must be multiple of 4. For example, 24 is a multiple of 4. Just, any number that ends with 24, like 4, 3, 24, it will be a multiple of 4, this entire thing. 5, anything ending with 0 or 5. That's it. 6, anything which is a multiple of 2 and 3 both. Okay. 7, there is no rule, there is no easy rule. The rules are very complicated in case. It's better to divide and check. That's it for 7. 8, last 3 digits must be multiple of 8. For example, 104 is a multiple of 8. So any number like 57104 would be a multiple of 8. 9, sum of digits must be multiple of 9. Okay. For example, take any number, 63. 6 plus 3 is what? 9 divisible by 9. That's it. 10, I know it must end with 0, obviously. And we don't have to know the divisibility rule for higher numbers. It's not required. Okay. No question will kind of check you on that. Right? And just one more thing before we move to questions again, which is the last digit of an exponent. Okay. Now, for example, the question is, what is last digit of 3 raised to power 82, let's say. Last digit means, if we write the number, what's the unit place number for 3 raised to power 82? Let's say if that is the question, what do we do? Just write first 4 powers. 3 raised to power 1 is 3. 3 raised to power 2 is 9. 3 raised to power 3 is 27. 3 raised to power 4 is 81. The last digit is 3971. If we keep doing that, 3 raised to power 5 will end with 3. 3 raised to power 6, I'm just writing the last digit. End with 9. 3 raised to power 7 will end with, 3 raised to power, 7. 7 will end with 7. 3 raised to power 8 will end with 1 and so forth. This sequence of 4 digits keeps repeating itself. Okay, this is what we call as cyclicity. This sequence keeps repeating. Okay. Now, for example, 3 raised to power 82. So if we keep writing, it in groups of 4, 3 raised to power 80 will be somewhere here. Then we'll again start with 3 raised to power 81, 3 raised to power 82. So the last digit would be nothing but 9. Okay, got it, everyone?
For all numbers, it will repeat in cycle of 4 only, or it will
I'll come to that. Let's deal with 3 first. Okay, we'll come to that point also. So the point here is the power 82 divided by 4 and see what is the remainder. Remainder is 2 in this case. We just have to check for 3 raised to power 2. Okay, and the reason is because we are talking about groups of 4. Okay, this thing repeats in groups of 4. That's why we are dividing by 4. And whatever the remainder is, we'll just have to check with 3 raised to power 2. Okay, is it clear with 3 first of all? Any doubts about 3? Okay, now what about cyclicity? Is it 4 for everything or different, right? Jay, this is what you're asking? Does it repeat after 4 with every number or something
Yeah,
else?
exactly.
Okay. Now, cyclicity could be 4, as is the case with 2, 3, 7, we'll see. Cyclicity could be just 1. 1 means it's always the same number. For example, 5. 5 raised to power anything will always end with 5. 6 raised to power anything will always end with 6. 1 raised to power anything will always end with 1. But the cyclicity could be 2, as is the case with 4. 4 raised to power 1 is 4. 4 raised to power 2, 16. 4 raised to power 3, 64. 4 raised to power 4, 256. Okay, so 4, 6, 4, 6. So in that case, we just have to look whether the power is even or odd. That's it. Okay, as is the case with 9. 9 raised to power 1 is 9. 9 raised to power 2 is 81. Last digit is 1. 9 cube 9. 9 raised to power 4 1. So we just have to see whether the power is odd or even. Cyclicity is either 1, I mean it's always same, or it's 2 or 4. That's it. It's never more than 4. So in case you're confused whether cyclicity, I mean what's the cyclicity of any number, just write first 4 power. If nothing repeats till 4, cyclicity is 4. Otherwise, you'll get to know whether it is 2. Okay, Jay, clear? It's never more than 4. Write first 4 powers. If it repeats before, you know it's 2. If it is if nothing repeats till 4, it's 4. That's it. Okay, and for example, let's say if we have 123 raised to power 82, we don't have to check for this. We just have to check for the last digit, 3 raised to power 82 only. Okay, not for the entire number. Okay, and what do we need to do? 82 the power divided by 4. Just see what is the remainder, 2. Okay, and for other numbers, we just, for example, the cyclicity is 2. We just have to see whether the power is odd or even. That's it. Nothing, in terms of remainder or something, we'll have to see. Okay. Okay, are we clear on everything here that we've did, that we've done? Any doubts with any point?
No.
Okay, let's see some questions in that case. We can start with 6th, 8th, 10 and 11. Yeah. 10, 11, 15. Yep. Yeah, 10, 11, 15. 6, 8, 10, 11, 15. Okay. I mean, these are not very difficult questions, so just take them easy. Let's see the questions. What's the units digit of this? So we just need to check units digit of 7 raised to power 28 minus 3 raised to power 23. Okay. 28 means multiple of 4, so 7 raised to power 1, 7 raised to power 2, 7 raised to power 3, 7 raised to power 4. So it'll end with 7, 9, 3, 1. So this will end with 1, 7 raised to power 28. Okay, 28 is a multiple of 4. It'll be 0 remainder when we divide it by 4. So we are talking about this. Okay, 7 raised to power 4, 7 raised to power 8, 7 raised to power 12, till 7 raised to power 28. 3 raised to power 23, 23 when divided by 4, remainder would be 3. So 3 raised to power 1, 3 raised to power 2, 3 raised to power 3. This would be 9. Sorry, 3, 9, 27. Okay. So, something ending with 1, something ending with 7. If we subtract it, it'll be 4. Okay. Some bigger number ending with 1, some smaller number ending with 7. I mean, when we subtract it, that's how it'll work. Right, everyone? Clear? Any doubts on this? Okay. 8th. When positive integer x is divided by 9, remainder is 5. So x is equal to 9 into some integer plus 5. That's how we write it. Okay. That's what we mentioned earlier. What's the remainder when 3x? 3x would be what? Multiply this entire thing by 3. 27 into some integer plus 15. This is what 3x is. Divided by 9. 27 into any integer by 9, remainder would be 0. I mean, it will be a multiple of 9. The remainder would be when 15 by 9, 15 is divided by 9, that will be 6. So that's your answer, 6. Okay, so writing it this way definitely helps. I hope this is clear.
So can you just repeat it once again?
So x divided by 9, remainder is 5. That's how we write it. Right? X is
Yeah.
equal to 9 into some integer plus remainder.
Hmm.
So we are talking about 3x. So 3x would be what? Multiplied by 3.
Yeah.
So 27 into some integer plus 15. When this is divided by 9, what would be the final remainder? Remember, x plus a plus b divided by 9, what would be the remainder? We just add the individual remainders.
Yeah.
27 I
Okay.
would be multiple of 9, 0 remainder.
Yeah.
The only remainder would be from this.
Got it.
Got it? So again, writing it in this form, x is equal to, x is equal to y into some integer plus remainder. This definitely helps a lot in understanding what is happening. Okay. So yeah, that's what it is. 10th, j and k are positive integers where k is greater than j. Okay. K is equal to j into m plus 5. That's given to me. Okay, so it's a quantity comparison question. Which quantity is bigger? That's what we're talking about. Okay. Value of the remainder when k is divided by j and 5. That's what we are comparing. Okay. So any answers for this? Anyone? Any answers?
I think it will be same.
Sorry? C. Equal. Okay. Anybody has any other answer? See, when we, I think, Jay, you are coming from this point of view that x is equal to y into integer plus remainder, right?
Yes.
This is you are comparing it with, right? I guess. Right. Now, what you're doing is fine. There is only one thing that we need to take care of, which is remainder is supposed to be less than the divisor always. Okay. See, in this case, if, let's say j is the divisor. If j is greater than 5, definitely remainder would be 5 in that case, right?
Yes.
Yes. But what if j is equal to or less than 5. For example, let's say j is 2. So we are writing as, let's say, 15 is equal to 2 into 10 plus 5. We can write it this way for sure. No problem. But would 5 be remainder? No. We are just writing it this way. It doesn't mean it's the remainder. Remainder obviously would be 1 in this case. We know that. So if j is less than equal to 5, then obviously the remainder would be less than 5. Are we getting this point, everyone? If j, let's say if j is the divisor, if it is greater than 5, then definitely from this we can say remainder would be 5 when k is divided by j. But what if j is less than 5? Then the remainder definitely would be less than 5. Okay. Remainder has to be smaller than the divisor. It can't be bigger. So the answer is D. D means we can't really say. Okay. A might be equal to B. A might be smaller than B. So if there is nothing which is consistent always, the answer is D. D means, again, we can't really say what will happen. Is this clear, everyone? Jay, got it? So that's the tricky part here with this question. Okay. I mean, see, that's how they make questions difficult. They don't make question by making it very difficult to solve or something. No, they'll make it difficult by making it, difficult to think about. Okay. Think about the possible cases. Okay. Lakshya, Abhilasha, clear? Here.
Clear.
Why it's
Yes,
not
sir.
C? It looks like C on face of it, but it's not equal. Okay. All right. T is divided by 7. Remainder is 2. So T is equal to 7 into some integer plus 2. Okay. Whatever it is. What's the remainder when t square plus 5t plus 6 is divided by 7? T square, 5t, and 6. So t square is what? T into t. We can multiply the remainders, individual remainders. So when t square is divided by 7, the remainder would be 4. Right? Okay. T into t is divided by 7. We can multiply the individual remainders. No problem. 5t, 5 into t. 5 divided by 7 remainder is 5. T divided by 7 remainder is 2. So it'll be 10. You divide it once more by 7, it'll be 3. So 5t divided by 7 remainder would be 3. 6 divided by 7 remainder is 6. If the number is smaller than the divisor itself, the remainder is the number itself. So 4, these are in addition. So 4 plus 3 plus 6 divided by 7, remainder would be 6. Okay. So at some point we are multiplying, at some point we are adding. That's all, depending upon how things are there. Okay. So this is purely what we did with the remainders initially. All right. Any doubts here? Let me know. 15th units digit of this m is equal to 5. 3 raised to power 4n plus 2. Okay. One thing must also be given here, that n is a positive integer. That must also be there. Okay. And just use it with this. N is a positive integer. So 3 raised to power 4n plus 2. What will be its last digit? How do we get that? We divide the power by 4 and see what is the remainder. 4n plus 2. Remainder will be 2 always. Doesn't matter what is value of n. Given that n is a positive integer. Is that clear? 4n plus 2 divided by 4. 4n by 4 remainder would be 0. 2 by 4 remainder is 2. So remainder would be 2 always, irrespective of what is the value of n. So 3 raised to power 2, last digit would be 9. So we are talking about 9 last digit with 3n plus 2, and m is 5. So last digit would be 4. Okay, got it, guys? Any questions, any doubts?
Yes.
All right. Now let's do some really tricky questions, 2, 3 of them. Okay. We've done easy, we have done medium level also. Let's do some really tricky ones, which is 4, 9, 12, and 13. 4, 9, 12, 13. Okay. Give them a try. In fourth, I'll give you one hint. Take total length as 35 units instead of 1 unit. Okay, the given is 0 to 1 unit length, but just imagine there are total 35 units in that 1 unit. Okay, just go with that. I'm giving just a hint. Okay, try it. I mean, try these 4 questions. Okay, let's see the questions. We're running out of time. Okay. So fourth question. On the number line, the line segment from 0 to 1 has been divided into 1/5. So 1/5, 2/5, 3/5, 4/5, and 5/5. So five marks of this as indicated by the large marks, and also into 1/7 like 1/7, 2/7, 3/7, and so forth, as indicated by small tick marks. Now the idea is we are talking about 1/5 and 1/7. LCM of 5 and 7 is 35. Okay, LCM of 5 and 7 is 35. So let's assume this entire line is 35 units. Okay, everything is like 35 times, let's say. Okay, we'll divide the final answer by 1 by 35 by 35 eventually. Okay, so 1/5 would be like 7, 14, 21, 28, 35. These are 1/5. 1/7 would be 4, sorry, 5, 10, 15, 20, 25, 30, 35. What's the least possible distance between any of the two tick marks? Least possible is either 14 or 15 or 20 or 21. Least possible is 1, but it's actually 1 by 35. Okay, because everything was scaled up by 35 units. Okay, we are considering 1 as 35. That's why. Right? Is that clear? Jay, when you say 0.028, is it 1 by 35? That's what you mean, or what? Sorry?
It's 1 by
Uh, I couldn't hear anything.
Yeah, that is 1 by
That's
35.
1 by 35. Okay.
Yeah.
All right. Okay. Is that clear? Lakshay, Abhilasha?
Yes, sir.
Yep. So the idea is, not to start with 1 by 5, 2 by 5, 3 by 5. It'll take a lot of time, will involve a lot of calculations. Take LCM of 7 and 5 and consider it as the bigger unit. That's it.
So, like, is it the type of question where here we have to enter the answer? Like, there are no options.
No, there could be options. There will be options. Most likely there'll be options. Okay. But when you have to type the answer, it could be any kind of question in that sense. I mean, there's nothing fixed. Okay. Ninth, when the integer x is divided by integer y, the remainder is 60. Okay. Which of the following is a possible value of the quotient x upon y? Okay. Remainder is 60. Okay. Now, something divided by y is equal to some number plus remainder. Okay. Or let's put it this way. X is equal to y into some integer plus remainder, which is 60. Okay. Now you divide everything by y, what do you get? X upon y is equal to integer plus 60 upon y. Okay, that's what we are talking about. Clear? Now tell me one thing. The remainder means it's not divisible by y, the divisor. So 60 by y should be equal to the decimal part. Can we say that? Where is the decimal part coming from? From the remainder only. Had there been no remainder, had there been zero remainder, there will be zero thing after decimal. Okay, so are we clear on this? This 60 upon y is giving me the remainder part, 0.15, or 60 upon y is 0.16 or 0.17, that way. Okay, is that clear first of all? Jay, Lakshay, Abhilasha?
Yes, sir.
Right. Now, y is equal to 60 upon 0.15 or y is equal to 60 upon 0.16. The idea is y is an integer. So 60 upon 0.5, can it be an integer? Yes, it can give me an integer, yes. 60 upon 0.16, can it give me an integer? Let's see. 60 into 100 upon 16. 16 is 4 into 4. Yes, it can give me an integer. So this is also possible. But 60 upon 0.17 cannot be an integer. So, the value has to be an integer, y. So this will not be this will not give me as an integer. These two definitely can give me an integer. These two are possible values. Okay. These two are possible values for the quotient. Got it? So whichever value can give me remainder, that's all I'll go with. Okay, I don't need to do anything else. Okay. Let's see. 12th. Any answers for 12th? For any integer case. So this is a kind of a question, definitely it's a difficult question. Integer k is greater than 1. The term length of an integer refers to the number of positive prime factors, not necessarily distinct, whose product is equal to k. For example, if k is equal to 24, length of k is equal to 4 because 24 can be written as this way. So 24 can be written as 2 cube into 3 raised to power 1. So length, what it is calling as length is the sum of the powers, the exponents. That's what it is calling as the length. Okay, is that point clear first of all? What is it calling as length? The powers of the prime factors. That's it. I mean, adding all the prime factors, their powers. Okay, that's what it is calling as length of the integer. X and y are positive integers such that x is greater than 1, y is greater than 1. Okay, but x plus 3y is less than 1000. X plus 3y is less than 1000. What is the maximum possible sum of the length of x and length of y? Now, to maximize the length, we need to maximize the powers. Power would be maximized when the base is smaller. Base is smaller means consider x as 2 raised to power something. So base is smallest. Okay. So base of, let's say, x has a base. I mean, x is equal to 2 raised to power something. Right. So 2 raised to power, what can we have? 2 raised to power 9 because 2 raised to power 10 will be like greater than 1000. So the max we can go with 2 is 2 raised to power 9, which would be 512. Okay. Everybody understood why we are taking 2? We want to take the smallest number so that the power would be maximum. Because we need to maximize the length. Length is nothing but sum of the powers. Okay. So in that case, if 2 raised to power 9 is there, it'll be 512. So 3y should be less than what? 488, because the sum has to be less than 1000. Okay. Or y has to be less than 162 something. Okay. Now, again, for x we have taken as 2 as the length, and y the next smallest prime number other than 2. I mean, the next number could be 3 because we already taken 2. So y is equal to 3 raised to power something, and that 3 raised to power, it can only be what? Maximum. How much power it can be for this to be less than 162? 3 raised to power 4, right? Okay, is that clear, guys?
Like why can't it also be two something?
Does it say y and x and y need to be different? No, it doesn't say. Okay, in that case, y can also be 2 raised to power something, right? I think I thought of x and y as different, but nowhere does it say that x and y must be different, right? So y can also be 2 raised to power something. So 2 raised to power what? Till what point it can go? 128, which would be 2 raised to power 7. Okay. So for x the power is 9. For y, the power is 7. 16, right? It doesn't say x and y need to be different. So, I mean, the base has to be different. No, it doesn't say that thing. So 2 raised to power 9, that's what x can be maximum. And 2 raised to power 7, that y can be. Okay, again, we want to maximize the power. That's it. Got it, everyone? Any doubts?
Yeah, good.
All right. So definitely this is a difficult question. And then 13th. A, B, C are positive integers and A, B, C are assembled into a 6-digit number. So this is a 6-digit number. Which one of the following must be a factor of A, B, C, A, B, C? Okay. Now, if we write a number x, y, how do I write a number? I can write it as 10x plus y, right? Okay. If I write a number A, B, C, I can write it as 100A plus 10B plus C. Same way, if we have ABC, ABC, I can write it as 10,000 A, 5 zeros, sorry, 100,000 A plus 10,000 B plus 1,000 C plus 100 A plus 10 B plus C. That's what I can write it as. Okay, so it will become what? 100, 100 A plus, I mean, did we write it correctly? Yeah. So B plus C. Yeah, that's what it is. Okay. So I can take 1001 out. So we have what? 100A plus 10B plus C. Okay. This is what we have. Which is the following must be a factor of this. 1001, what would it be divisible by? I mean, which number out of these would divide it? 16, would it divide it? No. 13, does 13 divide it? Yes. I mean, if you divide it by 13, 13 divides it, definitely it's a factor of 13. See, we can't say anything about ABC, what those numbers are. Okay, but definitely this would be a common thing when we do this. We can write it in this way, and definitely 13 would divide it. This number would definitely divide it. Okay, question is must be a factor. Must be means others might be, might not be, but 13 definitely would be a factor here. Okay, understood, guys? Any doubts? Any questions? So, I mean, if we divide 1001 by 13, what do we get? So, I mean, had the numbers been 7 or 11, those numbers definitely would also be factors, must be. Okay. Because 1001 can be written as 13 into 7 into 11. So 13 is there, so definitely that is there. Had there been 7, that also would be definitely a factor. 11 definitely would be a factor. Clear, everyone?
Like I also got 13, but I did it different way.
What did you do?
So I like basically eliminated A, C, and D. Like 16 cannot be there because the number can be odd. So 16 won't be a
Okay,
factor.
okay. Definitely the number can be odd. Yes.
So
5,
only 5 can also not be there because it may.
it might not end with 0 or 5.
And 3 also, like we can make some of the 6 numbers
How do
not.
you eliminate 3?
So we can get
A
numbers
plus B plus C might not be a multiple of 3, right?
2 times A plus B plus C.
2 times. I mean, again, A plus B plus C must be a multiple of 3. Then only, we can say 2 times of that would also be multiple.
But 30 like
Okay.
we can do anything. So
But
I
how did so you zero down to 13 by eliminating other options?
yeah, and for 13 like I just took randomly 4, 5 numbers and divided all by
Okay. And you figured out that every time will be a multiple of 13. Okay. Now, see, first of all, is this, whatever we did, is that clear? Right? Lakshya, Abhilasha, whatever we did, understood? Okay.
Yes, sir.
Now, see, there could be problem, Jay, with that method. We can have questions where there could be multiple correct options. Okay. We have questions in GRE where we are selecting multiple options. Now, if 13 is also there, 7 is also there, 11 is also there, then there will be a problem with that method. Right? Jay? Okay. Because with once we have only one correct option, you can eliminate the wrong ones easily. But if we have multiple correct options, it'll be a challenge. Okay.
Okay.
So this is how we can go about it, and that's how we do it. Okay, so that's it for today, and let's meet tomorrow. We'll start with RC tomorrow, and make sure you attend that session. Don't miss that at all because it'll be a very, very important session. Okay. All right, guys. Thank you. Bye bye. See you tomorrow.